Hello students, welcome to Resonance. Now we are going to start the paper discussion of IOQM and we hope that everyone got the good marks and everyone will go to the next stage. So without wasting time, we'll start question number 1. So question number 1 says that if 60% of a number x is 40, then what is x percent of 60? Means 60% of a number. 60% of a number x is 40. So first we'll find x, then we'll use what is x percent of 60. So 60 by 100 into x equals to 40, or we can say x will be 400 by 6 or 200 by 3. So x is 200 by 3. Now we have to find what is x percent of 60. Means 200 by 3% of 60, or you can say 200 by 3 into 100 into 60. So this is cancelled, 3 to 20. So answer is 20 into 2, that is 40. So correct answer for question number 1 is 40. Now we'll move to question number 2. Find the number of positive integer n less than or equals to 100 which are divisible by 3 but are not divisible by 2. First main focus is positive integers, means n will be equals to 100 but n will not be negative number. So first we'll find which are the multiples of 3 from 0 to 100. So first multiple is 3, then 6, then 9, last will be 99. Equals to 100 we have to take, okay. So overall these are 33 numbers. Overall these are 33 numbers. And second condition is that they are not divisible by 2. So 3 into 2 is 6. So 6, 12, 18. These are the number which are in the table of 3 also, or you can say multiple of 3 also, but they are divisible by 2 also. So that is why we have to remove these numbers. So 6, 12, 18 and last will be 96. 6 into 16, 96. Next number is greater than 100. So these are 16 numbers. These are 16 numbers. So finally we are left with 33 minus 16, that is 17. So 17 numbers are there which are divisible by 3 but not divisible by 2. So answer is 17. So next question number 13. The area of integer sided rectangle is 20. What is the minimum possible value of its perimeter? See, the sides are given as integers. Integer can be negative and positive also. But rectangle length is there, length dimension, length is never negative, so we have to take the side as positive only, okay. So suppose the length is x, breadth is y, so area is x into y is 20. So possible values are 1 and 20 because 1 into 20 is 20. Second pair is 2 and 10. Third is 4 comma 5. These are integers only, so that is why we are taking integer values. We cannot take in fractions. These are integer values. So if you take 120, so perimeter will be 2 into 1 plus 20, that is 42. If you pick second pair 2 and 10, so into 2 plus 10, then the perimeter will be 24, 2 into L plus B. If you pick third pair 2 into 4 plus 5, that will be 18. So we need to find minimum possible value of its parameter. So minimum value is 18. So our correct answer is 18 for third option. Now we move to the fourth one. How many isosceles integer sided triangles are there with parameter 23? Okay, first we will draw the triangle. Because it's an isosceles triangle, the two opposite sides are equal and base is different. The two opposite sides you have taken as A, third as B. So parameter is 23. This means A plus B is 23, or I can say 2A plus B is 23. Now because this is a triangle, so to satisfy the condition that sum of two sides is always greater than the third side for all the three pairs, means A plus B is greater than A, okay. A plus A is greater than B, again A plus A is greater than B, or you can, this implies that 2A is greater than B. Now we'll use the inequality because from this B is 23 minus A, and using this relation, because 2A is greater than B, we'll substitute the value of B here. 2a will be greater than 23 minus a. Okay, 23, sorry, 2a, this is 2a, 23 minus 2a. So 4a will be greater than 23, or a will be greater than 23 by 4, or I can say a will be greater than 5.75. The value is in decimals, so we have to take integer value. So nearest possible value, because we have to pick greater than 5.75, so a will be 6. Second side, because 2 point sides are equal, again a will be 6, so our b will be 11, because we have to form the pair 23, parameter is 26 plus 6 plus 11. Now we can take a as 7, a as 8, a as 9, a as 10, and a as 11. So here also a will be 7, a will be 8, a will be 9, a will be 10, and then a is 11. From this we can find b as 9, b as 7, b as 5, b as 3, and b as 1. So these are the 6 possible pairs for isosceles triangle. Because if you see 6 plus 6, 12 is greater than 11, 7 plus 7, 14 is greater than 9. So every time this pair will satisfy. We cannot take a as 12, because 12 plus 7, 24, parameter is 23 only. So 6 possible pairs are there, so 6 triangles with interior sides where the parameter will be 23. So answer is 6. Now we move to the next question. How many 3-digit numbers ABC in the base 10 are there with A not equals to 0 and C equals to A plus B? Okay, so if you see ABC, because this is a 3-digit number, so ABC will be from 0 to 9, but condition on A is that A cannot be equal to 0. So we can take A from 1 to up to 9. B, there is no condition of B, so B can take value from 0, 1 up to 9. And C is dependent on A plus B. C is dependent on A plus B. So obviously C, because all three are the number digits only, so C also vary from 0 to 9. So possible pairing, because A value is 9, B is 10, so possible pairing will be 10 into 9 by 2, because repetition is also there. So it is 90 by 2, or you can say that 45, which will satisfy all these conditions. So there are 45 numbers which will satisfy our condition. Okay. Now move to the next question. 6th. The age of person in 2025 is a perfect square. His age is also a perfect square in 2012 also. But after m years from 2025, his age will be perfect cube. So you have to find the smallest value of m, means whatever his age in 2025, after adding that m value, his age will become a perfect cube. Okay. So let us take that his age, let his age in 2025, because it's a perfect square, so we'll take a square. Okay, a square. Same in 2012, again it's a perfect square, so we'll take b square. Okay, b square. And if you see the difference between 2025 minus 2012 is 13, there is a gap of 13. So from this we can take a square minus b square as 13, or you can say a plus b into a minus b is also 13, a plus b and a minus. And this shows that product of two number is 13, and 13 already is a prime number. So there is only one possibility, 13 into 1. 13 into 1. So from this we can assume that a plus b is 13 and a minus b is 1. So by elimination, 2a is 14, a is 7. A is 7. This means that in 2025, because we have taken age as a square, means 7 square is 49. So his age in 2025 is 49. Now we need cube, perfect cube. So 3 square is 27, sorry 3 cube, and 4 cube is 64. So after 49, 64 is a perfect cube number. So we need 15 more years. 15 more years. So smallest possible value of m will be 15, because 49 plus 15 is 64, and this 64 is a perfect cube number. So our correct answer is 15. Now we move to the next question. The sum of two real numbers is a positive integer n, and the sum of their square is n plus 1012. Find the maximum possible value of n. We have to find maximum possible value of n. So let us take two numbers as a and b. So a plus b, and a plus b is a real number. Two real numbers are two real numbers. Sum of their squares means a square plus b square equals to n plus 1012. 1 n plus 1012. Okay. Now if let us take this as 1, is that let us say this is 2. So if you take squaring on first equation, a plus b whole square equals to n square. Okay, so this will be a square plus b square plus 2ab equals to n square. We have the value of n square, a square plus b square, that is n plus 1012 plus 2ab equals to n square, or 2ab will be n square minus n minus 1012, or this implies that AB will be n square minus n minus 1012 divided by 2. N square minus n minus 1012 by 2. We have the value of AB. Now because a and b are real numbers, so for any real coefficient, the equation will be t square minus nt plus ab equals to 0. This is the rule for any real coefficients. Okay, and the discriminant is also greater than or equals to 0. Discriminant. So this is n square minus 4ab greater than or equals to 0, or n square minus 4 times ab, we have n square minus n minus 1012 divided by 2 greater than or equals to 0, or you can say n square minus 2n square plus 2n plus 2024 greater than or equals to 0, or minus n square plus 2n plus 2024 greater than or equals to 0. Okay, now if you take negative common, so n square minus 2n minus 2024 will be less than or equals to 0. Less than or equals to 0. Now we use a factorizing middle term. If you factorize it, minus 46n plus 44n minus 2024 less than or equals to 0. From this, n minus 46 plus 44, if you take common, n minus 46. So n minus 46 and n plus 44. So the range of n is from minus 44 to 46. These are the possible values of n, minus 44 to 46. But if the question says that we need maximum possible value of n, so maximum possible value will be 46. Okay, because we have the range from minus 44 to 46. So maximum possible value is 46. 46 are correct answer. Okay. Next, a quadrilateral has 4 vertices A, B, C, D. We want to color each vertex in one of the 4 colors. We have 4 colors: red, blue, green and yellow, so that every side of quadrilateral and the diagonal AC, A, B, C, D, have end points of different colors. So in how many ways we can do this? Okay, so if we start from A, because 4 colors are there, so A have the 4 choices. A can take any 4 color, hai na? Now if A has picked up 1 color, so B will be left with 3 choices and C will be left with 2 choices. Okay, but if we go in the sequence, there is a possibility that B and D can have same color. Means D can be different from A and C. Okay, D should be different from A. So again D has 2 choices. because one color is picked by A, one color by C. So again D have two options. So overall possibilities or overall ways can be, it's 4 into 3 into 2 into 2, that is 48 ways. So overall, to have different colors, we have total 48 ways. Okay. Now we move to question number 9. Four sides and diagonal of a quadrilateral are of length. These are a quadrilateral and a diagonal. Lengths are given as 10, 20, 28, 50 and 75. But they are not in the order. Any place we can pick up the values. Which among them is the only possible value of diagonal? So these are 5 sides are given. One of them is diagonal. See, if you see this diagram, from this diagonal we have one triangle. This is one triangle, this is another triangle. There are two triangles on either sides of a diagonal. So the property of triangle is sum of two sides is always greater than the third side. And for quadrilateral, sum of three sides should be greater than the fourth side. So suppose we pick 20 as diagonal. Let's assume. So 10 plus 28 is greater than 20. Okay. But if you pick 10 plus 20, okay, now because 20 is a diagonal, so 20 will be there in this pair also. So 50 plus 20 is not greater than 75. This is not satisfying. Okay, so by possibly arranging all the pairs, we see that 28 is the pair which is satisfying our condition. 28 is the diagonal length. Because you see 10 plus 20 is greater than 28, and sum of, if you pick diagonal as 28, the sides will be 20, 10, 20, 50 and 70. So these four pairs satisfying our condition also, where sum of three sides is always greater than the fourth side. So the length of the diagonal is 28. Now last question, next question, question number 10. The height and the base radius of a closed right side circular cylinder are positive integer. They are positive integer. Let us take radius as r and height as h. And its total surface area is numerically equal to its volume. Means 2 pi r into h plus r equals to pi r square h. And the volume is given as k pi. Volume is given as k pi. And the formula for volume is pi r square h. So if we cancel pi, r square h will be k. From this equation, 2 times h plus r equals to rh, or 2h plus 2r equals to rh. 2r will be rh minus 2h, or we can say 2r by r minus 2 equals to h. 2r by r minus 2 equals to h. Now for h to be a positive integer, because h is at 2r by, first thing is that from this we can imply that r will never equals to 2. R cannot equals to 2. Now for h to be a positive integer, this r minus 2, because 2r is a multiple of 2, so r minus 2 must divide 4. So factor of 4s are 1, 2 and 4. So if you pick r minus 2 as 1, r will be 3. If you take r minus 2 as 2, r will be 4. And if you take r minus 2 as 4, r will be 6. So from this equation, RH will be, when r is 3, h will be 6. When r is 4, h is 4. And when r is 6, h is 3. H is 3. H is 3. So K is r square h. So if you pick the values here, 3 square into 6, that is 54. From here, it's 4 square into 4, that is 64. From this, 4 square into 6, 96. So we need the smallest possible value of k. So the smallest possible value is 54. So our correct answer for k is 54. Okay. Now we move to the next question. So the sir will join for remaining questions. So the correct answer is this. So because in the question it is mentioned that we have to find the smallest possible value of k. So correct is 54.
Hello everyone. I'll just start with this question. So we're at the 11th question of our IOQM 2025 exam. I hope your exam went well. To start off with the question. So the question says, consider a fraction a by b, which is definitely not equal to 3 by 4, where a and b are positive integers with the, like a and b are co-prime, and b is less than or equal to 15. So the underlying condition is that b at max could be an integer which is like b could be an integer less than or equal to 15, or at max it could be 15. And if this fraction is chosen closest to 3 by 4 among all such fractions, then what is the value? So they're asking us to make up fractions of the form a by b, where b could be any denominator less than or equal to 15, and the fraction is purportedly to be very close to 3 by 4. So how do we approach this question? We could do it, since the keyword is closest, we could do it with identifying the gap between the fractions. So let's denote the gap between the fractions with d, which will be d is a by b minus 3 by 4. D is the difference of these two fractions. So taking the LCM, it will be 4a minus 3b by 4b, right? And the underlying value is that b is less than or equal to 15. In order for the fraction to be closest, the gap has to be very less, right? So when you have it on the number line, this is 3 by 4 and these are the possible values of a by b. The closest would be with the least gap with 3 by 4, right? And for the least gap, since this is a fractional form, the least value of this fractional form would be when the numerator is least and the denominator is the highest. So the least numerator, identically, since they have a modulus here, it could be like, ideally it could be 0, or since it could not be 0 because a by b is not equal to 3 by 4, it could be 1, right? So this could also be written as modulus 4a minus 3b by modulus 4b. So this could be 1. And the denominator has to be highest, where b is less than or equal to 15, right? So 4b is less than or equal to 60. So the highest possible value of 4b could be 60. Yes. So moving forward with this knowledge, so borrowing this modulus 4a minus 3b by modulus 4b. Modulus 4a minus 3b by modulus 4b. This has to be 1 and this has to be 60. So for this to be 1, if we remove the modulus, it becomes 4a minus 3b equals 1, or 4a minus 3b equals minus 1, right? When we remove the modulus, since mod x equal to k, x is plus or minus k, so 4a minus 3b is 1 or 4a minus 3b is minus 1. Now, the additional piece of information we have is, for the least distance, b has to be 15. And when b is 15, 4a minus 3 into 15 is 1, or 4a minus 3 into 15 is minus 1. So here it becomes 4a is what? 45 plus 1, 46, or 4a is here, 45 minus 1, 44. So here this is, since a becomes what? A becomes 11.5 is mathematically invalid because a is supposed to be an integer. So discarding this piece, we'll come to this piece of information where we get a to be 11, right? So the fraction a by b thereby becomes 11 by 15. This is the closest fraction to 3 by 4 where b could be the highest denominator. So based on this piece of information, the value of a plus b becomes 26, right? What is the value of a plus b? It becomes 26, right? Yeah, we'll move on to the next question. Considering 5-digit positive integers of the form a, b, c, a, b, which means it has repetitive digits that are divisible by the 2-digit number ab but not divisible by 13. So numbers of this form are grouped together. They're all divisible by ab but they're not divisible by 13. And they're asking us what is the largest possible value of the digits of such a number. So the number is ABCAB, right? This number could be written as AB000 plus C00 plus AB, right? Which is AB into 1000 plus 1 plus C into 100. So this is AB into 1001 plus 100C. But 1001 is what? The prime factorization of 1001 would be, it is 10 cube plus 1 cube. So 10 plus 1 into 10 square minus 10 plus 1. So it's essentially 11 into 91, which is again 7, 11, 30. So the underlying fact is that the number 1001 is divisible by 13. Since the number 1001 is divisible by 13, but the condition lies with this number being not divisible by 13, this portion has to leave out a remainder, which is 100C should not be a multiple of 13. 100C should not be a multiple of 13. So moving forward, AB into 1001 plus 100C is also divisible by AB, right? Since AB divides this, AB also has to divide 100C. Yes, if AB is dividing 100C, AB could possibly be 25, 50 or 75. That's it, right? The 2-digit numbers that could possibly divide 100C can only be 25, 50 and 75, right? Now, what is the largest possible sum of the digits of such a number? So for the largest possible sum, you need to take out the number AB in such a fashion that when you have the sum of digits, it leads to the largest possible number of the sum of the digits. So in order for that to happen, let's pick out AB as 75. If AB is 75 and 100C is divisible by 75, 75 fours is 300. Yes, and 75 12s is 900. So the maximum possible value C could take is 9, right? For 9, obviously the maximum possible value of C would be 9, but in that case, the mathematical validity of this divisibility also holds true. So in order to bring out the symphony between these, A, B could become 75 and C could become 9, where the number becomes 75975. Alright? This number is also not divisible by 13. Why? Because this portion could be divisible by 13, but 100C, which is 100 into 9, 900, is definitely not a 13 multiple. So the sum of the digits would be 75975. This is what? 24 plus 9, 33. Yes. So this is about the question for us. The largest possible sum of the digits of such a number formed with A, B, C, A, B would be 33. Going to the next question, the question says three sides of a quadrilateral are A equal to 4 root 3, B equal to 9 and C equal to root 3. The sides A and B enclose an angle of 30 degrees and the sides B and C enclose an angle of 90 degrees. If the acute angle between the diagonals is x degrees, what is the value of x? Yeah. So for this question, my instinct would be to go for something more, something less confusing. So we could go for the coordinate system. Let's draw up a coordinate system where, we can try to take B as the origin, the vertex B as an origin, where A could be this. And since C encloses an angle 90 degrees, the possible diagram for this would be this: A, B, C and D. So let this be the quadrilateral, and this side is what? That side is 4 root 3, this is 9 and this is root 3. So based on this, what do we get? Since this is origin and this is 9 units right to origin, it would become 9 comma 0, and this is on the same x value as C, so this would become 9 comma, the height is root 3, so it becomes 9 comma root 3. Again, after 9 comma root 3, what does this become? Since this is a 30 degrees, 4 root 3, so this shall be 4 root 3 cos 30, which is 4 root 3 into root 3 by 2, so obviously 6, and this would be 4 root 3 sin 30, 4 root 3 by 2, which is 2 root 3. So A would be 6 comma 2 root 3. Now that we got all the vertices in terms of coordinates, let's write down what are they asking us? The acute angle between the diagonals. So perpetually the diagonals are AC bar and BD bar. So AC bar would become what? AC bar would be the position vector of C minus position vector of A. So 9 minus 6, 3i, 0 minus 2 root 3, minus 2 root 3j. And then BD bar. So apart from that, BD bar would be BD bar, position vector of D minus position vector of B. So it would be 9i plus root 3j. Now that we have the vectors, we'll just, for the angle, like for the acute angle between two vectors, we just take the dot product of those vectors, which identically refers to AC dot BD bar is mod AC bar mod BD bar into cos of the angle between them. Cos of the angle between them, right? So AC bar dot BD bar is what? 3i, 9i, 27 minus 2 root 3 plus root 3. Minus 2 root 3 into 3 is minus 6, which is mod AC bar, which is root 9 plus 12, which is root 21. BD, mod BD bar is what? Root 81 plus 3, 84 into cos theta, which is the acute angle between the diagonals. So this is 21 equals 21 into 2 into cos theta, because 84 is 21 fours, so root 21 into root 21 is 21 and root 4 is 2. So cos theta becomes 1 by 2. Since theta is acute, theta takes a value 60 degrees. Did we arrive at the answer? The acute angle between diagonals is x degrees. What is the value of x? Since theta came out to be 60 degrees, the value of x would be 60. Right? Yes. So let's go to the next question. Yeah, so what do we have in the question here? A function f is defined on the set of integers such that for any two integers m and n, the function becomes what? F of mn plus 1 equals f of m, f of n minus f of n minus m plus 2. This, like, they're giving us a piece of information that says for any two integers m and n, this functional equation holds good, and that f of 0 equals 1. Right? Since f of 0 equals 1, what do we get? Let's first solve this functional equation before we get into the next part of the question. For solving this functional equation, let's put m is 0. If m is 0, what do we have? F of 0 into n, anyway 0, so f of 1 equals f of 0 into f of n minus f of n minus m is 0, so 0 plus 2. Right? Now, what do we have here? F of 0 is 1. Since f of 0 is 1, this becomes 1. So 1 into f of n would anyways be f of n. Since this is f of n minus f of n gets nullified. So f of 1 becomes 2. This is for the part of story where m is 0. Where if n is 0, it is still f of 1. F of 1 equals f of m into f of n, where n is 0. So f of 0 is 1 minus f of n is 0, so f of n is f of 0 is 1. So minus 1 minus m plus 2. So f of 1 is again what? 2. So 2 gets cancelled and we're left with f of m is m plus 1. Alright, so we just solved the functional equation. We just solved the functional equation to arrive at the solution of the functional equation just became f of m is m plus 1 for all integers. Now, to get to the second part of the question, determine the largest positive integer n such that summation of f of k from k is 1 to n is less than 100, which indicates sigma k is 1 to n, f of k is less than 100. So what does this indicate? This indicates f of 1 plus f of 2 plus f of 3 plus and so on plus f of n less than 100. And what did we get as the solution for the functional equation? F of m became m plus 1. So f of k becomes k plus 1. So f of 1 is what? 1 plus 1. F of 2 is 2 plus 1. F of 3 is 3 plus 1 and so on, plus n plus 1 is less than 100. Now what do we have here? 1 plus 2 plus 3 plus and so on n, which is the sum of first and natural numbers, so n into n plus 1 by 2 plus, there are n ones, right? So n less than 100. So it just became n square plus 3n minus 200 less than 0. Or you could also write it as n plus 3 by 2 whole square is less than 202.25. Alright, roughly approximating this, n plus 3 by 2 becomes less than, if it's less than 202.5, it's also less than 200. And sorry, this is square. So when we remove the square, n plus 3 by 2 becomes what? N plus 3 by 2 is less than root 200, which is 10 root 2. And root 2 is what? 1.414. So 10 into 1.414 is just 14.14. So n plus 1.5 is less than 14.14. So n is less than 12.14. 13 minus 12, 1 minus, yeah, so it's 12.26, right? So approximately something like that. It's 12 point something. So the largest value of n could be 12, right? What did the question say? Determine the largest positive integer n such that this holds good. For that to hold good, this inequality has to hold good, right? So since this inequality had to hold good, n just became less than 12 point something. So the largest positive integral value of n came around 12, right? So yeah, this is about the question. Next, what do we have in this question? There are 6 coupons numbered 1 to 6 and 6 envelopes also numbered 1 to 6. The first 2 coupons are placed together in any one envelope. Similarly, this third and the fourth are placed together in a different envelope. And the last 2 are placed together in yet another different envelope. How many ways can this be done if no coupon is placed in the envelope having the same number as the coupon? Yeah. So to summarize the question for you, we have 6 coupons, number 1, 2, 3, 4, 5, 6. We also have 6 envelopes numbered 1, 2, 3, 4, 5, 6 again. Now in this case, the condition is that out of the 6 coupons, we have 1 and 2 coupons grouped as one entity. We have 3 and 4 coupons grouped as one entity, and 5 and 6 coupons grouped as one entity. Since we have them grouped as one entity, the condition is that for this to happen, they are also giving us a condition in which no coupon is placed in the envelope having the same number as the coupon. So identically, since 1 and 2 coupon as a group is one entity, that entity cannot go into the envelope number 1 or the envelope number 2. So we have coupons C1, C2, C3, C4, C5 and C6, right? So they're grouped. Now this should never go to E1 or E2, envelope 1 or envelope. This should never go to envelope 3 or envelope 4. And this should never go to envelope 5 or envelope 6. Right? Since this is the case, we have, yeah, now get to it, get to the fundamentals. My essential idea of the question lies in something as basic as the inclusion and exclusion principle. How do we include and exclude based on that? First, when we include, we take all the cases minus, we take the cases where either 1 happens, C1 and C2 going to envelope 1 or 2, 1 mismatch, and when we remove the 1 mismatch cases, in that goes away 2 mismatches also. So let's add 2 mismatches. And when we add two mismatches, we'll also add the extra portion where there are all the mismatches. So remove all the mismatches. All mismatches. Yeah. So now let's get into the counting. Let's get into the counting. What are the total cases possible? To calculate the total cases, just forget everything. Think of it this way, that there are 10 coupons, right? There are 10 coupons, sorry, there are 6 coupons, and for the 6 coupons, there are 3 entities, like they're grouped into 3 entities. So for the first entity, there are 6 coupons. I'm not carrying any condition, plain calculation of the total number of ways, where the first entity has 6 ways. And the next entity, C3 and C4 together, has 5 ways. Out of 6, 1 is already gone, right? And then the third one has 4. So this becomes what? 26 is 120. 120 minus 1 mismatch. 1 mismatch as in either C1 or C2 going to even, like C1, C2 as an entity going to E1 or E2. C3, C4 as an entity going to E3 or E4, or C5 and C6 going to E5 and E6 as an entity. In that case, just remember, one mismatch, right? Say this is my case, remove that. We'll just multiply by 3, so it just comes out. When this go to E1 or E2, so let's write down 3 first. When this goes to E1 or E2, how many ways does it have? C1 and C2 going to E1 or E2? 2 ways, either E1 or E2, right? So 2 ways. After there are 2 ways gone, C3, C4 can go to any of the other things. So 5 ways. And once this is gone to, C5 and C6 can go to any of the 4 envelopes left. So minus 4. Sorry, into 4. So this is what? Again, 20 into 6. 120 again, plus 2 mismatches. 2 mismatches as in this go to either one of these and this go to either one of these. In that case, what do we have? Again, there will be 3 cases. So 3 into C1 and C2 going to E1 or E2. There are only 2 ways, E1 or E2. So 2. C3 and C4 going to E3 or E4. 2 ways again. 2. Finally, C5 and C6. C5 and C6 as an entity can go to any of these, like the remaining envelopes, which is 1 is taken here, 1 is taken here. So out of the 6, 4 are remaining. So 4 here, which is 3 into 4 into 4, 16. 16 into 3, 48. So 48 minus all mismatches. All mismatches as in this go to either of these, this go to either of these, and this go to either of these. So 2 chances, 2 chances, and 2 chances. So 2 into 2 into 2. So minus 8. So 120 minus 120, 48 minus 8 is what? 40. So they asked us how many ways can this be done if no coupon is placed in an envelope having the same number as the coupon. So we have 40 ways that this could be done. Alright? Yes, so let's move to the next question. Let fx and gx be 2 polynomials of degree 2 such that f of minus 2 by g of minus 2 is f of 3 by g of 3, which is 4. They gave us the values of g of 5 is 2, f of 7 is 12, g of 7 is minus 6, and they're asking the value of f of 5 in return. Alright, before we get into all that, what is the primary piece of information we have? The primary piece of information we have is this. So f minus 2 by g minus 2 is f of 3 by g of 3, and the ratio is 4. So separating the equalities, we have f of minus 2 is 4g minus 2. F of 3 is 4g3, right? So clubbing both of these, what do we have here? F of x minus 4g of x equals to 0, where x is minus 2 or 3. Yes. Now, f of x is a 2-degree polynomial. G of x is a 2-degree polynomial. So f of x minus 4g of x could at max be a 2-degree polynomial. It could be a linear, or it could be a constant, or it could be a quadratic polynomial. Now, f of x minus 4g of x is 0, and that has 2 roots. So it's definitely a 2-degree polynomial. So let's denote that with f of x minus 4g of x equals, let's take the leading coefficient to be a, x minus minus 2, x minus 3. So f of x minus 4g of x is a into x plus 2, x minus 3. Alright, now let's go to the next slide. We'll work it over there. F of x minus 4g of x is a into x plus 2 into x minus 3. F of x minus 4g of x a into x plus 2 into x minus 3. Now, it's as simple as g of 5 is 2. We need to find f of 5. F of 7 is 12 and g of 7 is minus 6. So, f of 7 minus 4 g of 7 is a into 7 plus 2 and 7 minus 3. F of 7 is what? 12. 12 minus 4 into g of 7 is minus 6 is a into 9 into 4. So 12 minus 24. So 12 plus 20, 36. 36 is what? 36 equal to a into 36. So a equals 1. Since a equals 1, f of x minus 4g of x just became x plus 2 into x minus 3. Now what do we have as the value of f of 5? G of 5 is 2 and they're asking us f of 5. Since g of 5 is 2, f of 5 minus 4 g of 5 is 5 plus 2 into 5 minus 3. So 5 plus 2 is 7, 5 minus 3 is 2. G of 5 is 2, so this is 8. So f of 5 is 8 plus 14, which is 22. They asked us to find the value of f of 5, and we just arrived at the conclusion that f of 5 is 22. Now, next, this is MTAI, which signifies the MTAI that conducts IOQM. MTAI is a parallelogram of area 40 by 41, delta is 40 by 41 square units, such that MI is 1 by MT, right? So let's just try to plot the parallelogram. M T A I. Before we get into anything, MT is what? Oh, they didn't give us anything about MT. Let's denote MT by X. We denoted MT by X. Now they're asking us MI is 1 by MT. Since MI is 1 by MT, this just becomes MI is 1 by X, right? MI is 1 by MT, so MI is 1 by X. Now, D is the least possible length of the diagonal MA, and D square is, okay. Before we go for that, let's denote this angle as theta. Now, how do we calculate the area of parallelogram? delta is 1 by x into sine theta, which is 40 by 41. So x gets cancelled. So sine theta is 40 by 41. So cos theta is what? Cos theta is root 1 minus 40 by 41 square. So 41 plus 40 into 41 minus 40. So 81 by 41, root 81 by 41 square. So 9 by 41. Since cos theta is this becomes 180 minus theta, right? Now, since this is 180 minus theta, I'll just go for the cosine rule or the parallelogram law of addition of the vectors. So, ma square is mi square plus mt square minus 2 mi mt cos, what is the angle included in here? 180 minus theta. So 180 minus theta. Oh, sorry. I'll just come back. జానీ లేడా అది ఇది Yeah, so what did we make the diagram? The diagram we made was, yeah, the diagram we made was this M, T, A and I, and this was 1 by x theta, 180 minus theta, and yeah, cos theta was what, 9 by 41, and this diagonal, so ma square, which is d square, would be mi square, 1 by x square plus x square minus 2x into 1 by x into cos 180 minus theta. X cancels, cos 180 minus theta is minus cos theta, so minus, so this becomes cos theta. So d square is 1 by x square plus x square plus 2 cos theta. So since this becomes d square is 1 by x square plus 2 cos theta, what do we have there? 1 by, this is what? This clearly indicates us to take an AMGM. 2 cos theta is 2 into 9 by 41. So when we take AMGM, they have to be equal terms because they are in the reciprocals. X square becomes 1. So d square least is 1 plus 1 plus 2 cos theta. 2 into 9 by 41. 2 into 9 by 41 is what? 18 by 41. So it is 2 plus 18 by 41. So 82 plus 1800, 100 by 41. Now, the least possible length of the diagonal MA and d square is a by b. So d square least possible length is 100 by 41. So they're asking us find mod a minus b. So mod 100 minus 41 is 59. Right? Yeah, so this is how we go for this question. Now, let n be the number of 9-digit integers that can be obtained by permitting the digits of 2, 2, 3, 3, 3, 4, 4, 4, 4. and which have at least one 3 to the right of the rightmost occurrence of 4. What is the remainder when n is divided by 100? Okay, so to think of this, if we just want to not go for too many cases, how would we go for this? We could go forward with considering the probabilities of the occurrence of 3, but that would be innocuous. Yeah. So instead of that, the keyword in all the combinatorics questions, whenever we have the keyword at least, it's the best way we could go forward is take a conjugate, take the complement. Since they have at least 1 3, at least 1 3 signifies what? 1 3 or 2 3s or 3 3s, right? So total minus no 3s to the right. Total minus no 3s to the right. Now get to it. Total is what? Total is, there are 9 digits, so 9 factorial by repeating digits are 2, 3 and 4. 2 factorial, 3 factorial and 4 factorial. So this is what? 720 into 789 by 2 into 6 into 4 factorial is 24. Yeah, so 24, 30s, 5. This is 4. 5 into 4 is 20. 20 into 7 into 9. 63 into 20 is what? 1260. So the total number of cases is 1260 minus no 3s to the right. If there are no 3s to the right, let's consider the last 3 digits. If there are no 3s to the right, if at all something is after 4, it could only be 2, right? So after the rightmost 4, it could be 2 or it could 4 could be the last digit. So the case where 4 could be the last digit, sorry. The case where 4 could be the last digit, or 4 could be here and here there could be a 2, or 4 could be here and there are 2 2's that follow 4. So in this case, 4 being here, if 4 is there, how many other numbers do we have? 8 factorial by arranging 3, 3, 2. So 2 factorial into 3 factorial into 3 factorial. In this case, there is 1 4 and there is 1 2. So in this case, 7 factorial by 1 4 is gone and 1 2 is gone. So 1 factorial into 3 factorial into 3 factorial. In this case, 2 2's are gone, so 2 is not at all there. 4 is gone, so 6 digits, 6 factorial by 3 factorial into 3 factorial. So what is this? 8 factorial is what? 720 into 7 into 8 by 2 into 6 into 6. So 6, 6, 36, 36 and 720, 20, 10. So this is 560. 560 cases here. And the next we have what? 7 factorial by 6 factorial. So 720 into 7 by 6 into 6. 6 into 6 is 36. So 20 into 7 is what? 140. We have 140 cases here. And from here we have how many? 6 factorial is 720. 720 by 6 into 6. So this is 20. So 560 cases and 140 cases is what? 600, 600, 600 and 100, 700, 720. So minus 720. So 1260 minus 720 is what? 1260 minus 720 is 540. So there are 540 cases where we have at least 1 3 to the right of the rightmost occurrence of 4. So remainder when n is divided by 100. So when this is divided by 100, the remainder is 40. Alright. Yeah, so this is about this question. Moving forward, do we have one question on triangles? Do we have it on solely on triangles? In triangle ABC, B is 90 degrees, okay? AB is 1 and BC is 2. So to draw the construction, could it be this construction? Uh, in all the in all the triangle cases, right angle triangle cases, B could be the vertex, like B, the right angled vertex could be where we consider origin. So yeah. Uh, let's go for the diagram. The construction could be in this fashion: B, A, C, 90 degrees at B. There are 2 points D and E on which side BC. So there's E lies between C and D. So D comes first and E comes here. B is 0, comma 0. So A becomes what? This is x-axis. So A becomes what? If B is 0, comma 0, AB is 1. So this will be 1, 0. And BC is 2. So 0, 2. So this becomes 0E. Let's say the y coordinate is 0E and the y coordinate here is 0D. Yep. So after this, the construction further calls us to create a square which is DEFG such that F lies on AC. Yes. So F should be here. F lies on AC and G lies on the circle through B with center A. So G is here. G is here and this is the circle with center at A. Yeah. So, alright, what are they asking us? It's the area of DEFG. So this is a square. So let's denote the side length with A. Now the primary equations we could write are what? One thing is A is E minus D. E minus D shall be our primary equation, and after E minus D, one more equation that we could write is the radius is 1. So what do we bring out of that? F is what? F is on the same y level. So F is also at A. Since this is A, this also becomes A. So A. So F becomes A comma E, and G becomes what? A comma D. G is A comma D. Yeah. So one more equation shall be G is on the circle. So A minus 1 whole square plus D minus 0 whole square, D square, is the radius of the circle is what? Okay, circle passes through B and center at A. So the radius is 1. Yeah. Apart from this, we have A is E minus D. Also, F lies on the line CA. What is the equation of CA? Equation of CA is what? Y minus 0 is slope is what? 0 minus 2 by 1 minus 0. So minus 2 into x minus 1. So y is 2 minus 2x. So F lies on this line, so E is 2 minus 2a. E is 2 minus 2a, and E, so from that D is what? D is E minus a. E minus a as in E minus 2 minus 2a minus a, 2 minus 3a. So a minus 1 whole square plus 2 minus 3a whole square equal to 1. So this is our equation. A minus 1 whole square plus 2 minus 3a whole square is 1. A minus 1 whole square plus 2 minus 3a whole square equals 1. Right? Now, what do we have left? I think we're pretty much close. The area of the square is a square. So we just need to find a square from this, where a is what? A is distance between E and D. So a is obviously less than 2. Yeah, a is less than 2. So bring it on. A square minus 2a plus 1 plus 9a square plus 4 minus 2 into 3a. 2 into 2 into 3a is what? 4 into 3a. 12a. 12a is 1. So we have 10a square minus 14a plus 4 is 0, which is 5a square minus 5a square minus 7a plus 2 is 0. So 5a square minus 5a. So a is what? A could be 2 by 5 and 1. 2 by 5, 7 by 5. Yeah, 2 by 5 and 1. Could A be 1? If A is 1, E minus D is 1. If E minus D is 1, if A is 1, D is minus 1, which is clearly not possible because D is on the line segment BC. So D has to lie between 0 to 2. So A could not be 1 from here. So A could not be 1. So A is 2 by 5. And the area of the square is what? Area is A square, which is 2 by 5 whole square, 4 by 25. What is asking us to find? 4 by 25, where 4 and 25 are obviously positive integers with GCD 1. So the value of m plus n is 4 plus 25, which is 29. Yeah, pretty much calculated. Yeah. So they defined a function which identifies as the remainder when n power n is divided by 7. N power n is divided by 7. For all positive integers n. Find the smallest positive integer such that f n plus t is fn. Identically, they're asking us for the principal period of the function f, right? So before we get into that, let this sink in terms of n. So let's just express n as 7p plus r or 6q plus s. As in, when we divide n with 7, let the remainder be 7r, and when we divide n with 6, let the remainder be s. Now, what do we have? N power n power 6 is what? N power 6, as in n power 6 is 1 mod 7. N power 6 is 1 mod 7. And it's also, when we divide n with 7, the remainder was n. So n is r mod 7. N is r mod 7. So n is r power n mod 7. And when n could be expressed as 6, q plus s, r power n becomes what? R power 6q plus s. R power 6q is 1 again. So r power s mod 7. So n power n just became r power s mod 7. Simple intuition based on CRT, Chinese remainder theorem, we could arrive at, since we have 6 and 7, we'll fix it with mod 42. So that goes for the principal period which is t being 42. So sir shall continue from here.
Hi everyone. So just a few more questions. As I hope it's audible. Okay. So, all right, let's go through this. For some real numbers, m and n, and a is a positive integer, these three numbers, a plus 1 into n square, m square, and a into n plus 1 whole square, is three consecutive integers in increasing order. All right. What is the largest possible value of m square? Note that m square is the middle term over here. These two don't even involve m. So all we got to say is this must be some number k minus 1, this must be k, and this must be k plus 1. Basically, the difference between these two numbers needs to be 2. And it needs to be an integer. Both these numbers need to be integers. Okay. So what do we have? A plus 1 okay, minus of a plus 1 into n square plus a into n plus 1 whole square must be equal to 2. Right? So this number is bigger than that. So this number written first minus that number, that must be equal to 2. Let's expand that out and we get, well, this piece is a into n square plus 2n plus 1. So let's group n square terms. N square terms, I see it as a over here and then minus of a plus 1 coming from this piece over here. And next we are left with 2an plus a minus 2 is equal to 0. Right? Okay. So let's just check if we got that right. So n square, yeah, that's it. So all of that is minus n square plus 2an plus a minus 2 is equal to 0. Now that's a quadratic. That's a quadratic that n is a root of, right? So n is a root of minus x square plus 2ax plus a minus 2. And let's remember that a is some positive integer. Maybe I'll just swap the signs. Okay, that's gone. This is minus. This one is also minus. Okay, that's good enough. So plus 2an minus all of that. Okay, so that goes there. Okay, now we can complete the square if that's one way to do it, or else we could just say that the discriminant of this quadratic has to be greater than or equal to 0, right? For some, okay, m and n can be any real number. These things should just be like that. Okay, so 4a square minus minus 4 into a minus 2 must be greater than or equal to 0. Right? Okay, so fine. It should be plus 1 because we have a minus sign there as well. So that gives us that you can remove the common 4. So a square plus a minus 2 must be greater than or equal to 0. Plus a minus 2 must be greater than or equal to 0. So this equation will always have a solution, right? Because this is nothing but a minus 1 into a plus 2 greater than or equal to 0. Now since a is greater than or equal to 1, this will be true. This is non-negative. This is anyway positive. So this will always be true. And we can also work out, we can also work out the value of n. So that must be, from here we can complete the square and we get n minus a whole square is equal to, that's just looking at these two terms. So a minus 2 is on the other side and then you have a square plus a minus 2 and that's all. So that must be an integer. That is an integer. So this tells us that n is a plus minus square root a square plus a minus 2. Alright, so that's what we have. Now, this number a plus 1 into n square needs to be a perfect square. No, needs to be an integer, right? So needs to be just an integer. So let's check that out. Okay, I'll just eliminate all these things. So anyway, the discriminant is non-negative. So really there's no information coming from that. Okay. Now what do we have? N square would be, okay, let's also multiply by a. So we have a times n square, and n, by the way, is that number. So we got to write a plus minus square root of a square plus a minus 2 and then whole thing square. This must be an integer. So let's see what that tells us. That is a into a square plus a minus 2 plus minus 2a square root, all of that must be an integer, right? In fact, it should be a natural number or a whole number, but that's good enough. That's good enough. So what do we have? All these things are anyway integers. So the remaining part must be an integer, meaning 2a square into square root of a square plus a minus 2 must be an integer, which means this must be a rational number. Right? Because a is also given to be positive. We could wonder about whether a is 0, but that's not the case. A is a positive integer, so this must be a rational number. So which means this must be a rational number. Therefore, a square plus a minus 2 must be square of a rational number, but that's an integer. The only square of a rational number which is also an integer is the square of an integer. Therefore, a square plus a minus 2 must be some k square, right? It must be square of an integer. All right, so now we got to figure out what possibilities are left for that. Okay, so a square plus a minus 2 is equal to k square, right? We could maybe just multiply by 4. That would give us 4a square plus 4a. Let's add plus 1 minus 9. The reason why I'm doing that is because that's a square is equal to k square. So that tells us, okay, by the way, since this side is anyway greater than equal to 0, I can pick k to be a whole number. So let's also say that k, I can choose it to be a whole number. Okay, so we have, yeah, and also k must be some even number, but that's okay. That will also follow from the very definition. So we have 2a plus 1 whole square minus k square is equal to 9. So that tells us that 2a plus 1 plus k into 2a plus 1 minus k is equal to 9. Now, since k is greater than equal to 0, this number is greater than the second factor. And since this is positive, that must also be positive. In fact, both of these are positive divisors of 9. They are in fact complementary divisors. So the options would be 9, 1, 3, 3. 1 and 9, I don't want to allow that because that would say k equal to minus k. I mean, it would be a negative number. So let's see what conclusion we get over here. We get 2a plus 1 plus k and 2a plus 1 minus k. These numbers are 9 and 1. So if you subtract them, you get 2k equal to 8, meaning k is 4. You can take that value of k and plug it over there, or you just add them both. You get twice of 2a plus 1 is the sum of these two, so divided by 2. So that would give us 5, and that would tell us that 2a is equal to 4 and a is also equal to 2. Okay, the other case, in this case, let's see what happens. Well, we can just mimic this. So you would just say it is 2a plus 1 is the sum of these two numbers divided by 2. In fact, k is 0. because both these numbers are equal, k is forced to be 0. So that means a is equal to 1 and k is 0. Right? We just have to work out two cases and that should tell us which one is winning. Okay. Um, I'll just record these facts over here. So a comma 1, no, a comma k is either 1 comma 0 or 2 comma 4. These are the solutions that we get from solving these equations. So let's just remove all of that. Just a plus b, a minus b, and we get all the solutions. Okay, but what do we really want? We want the value of m squared. So first we'll have to work out the value of n. Okay, now n satisfies a quadratic that also involves a. So let's just check that quadratic. We have that quadratic over here. Okay, so n square minus, or maybe I'll just go with that. N minus a whole square is equal to a square plus a minus 2, which by the way is k square. So, okay, maybe just write it over here. So that means that n itself is a plus minus the number k. Okay. Okay, so a plus minus k. So n would be a plus minus k, which means in our case it is either 1 or well, a plus k in this case is 1, a minus k is also 1, and in the other case it is 6 or is minus that, which is minus 2. Okay. So there are three cases that we need to work out. Now let's take a look at, okay, so this was a equal to, let's also write that, a equal to 1. These two cases, a is equal to 2. Alright, now what do we need to really work out? We need to look at these two numbers and m square would be the middle number in that case. So a plus 1 into n square. Okay, so a plus 1 into n square and a into n plus 1 whole square. Let's take a look at these two numbers. So in the case where a is equal to 1, n is equal to 1, we have, let's see what we really have. These two numbers would then be 2 into 1. So 2 here, and then a is equal to 1, which gives that is 1. Then n is equal to 1, so that would be 2 square, which is 4. And that's what we want. There should be a gap between these two numbers. That's where m square is going to fit. Okay, now the other case, a is equal to 2, n is equal to 6. Let's work that out. We have, okay, let's see. So a is 2 over there. So 3 into 6 square. 3 into 6 square is 3 into, okay, let me just quickly check if I got those numbers right. If a is 2, then k is, okay, that's 5 square. So 5 square minus 3 square, that's 4 square. So k is 4. All right. So n could be 6. Okay, so that's clean enough. Now what do we want? So 3 times 6 square, which is 36, and then 2 times 7 square, which is 49, right? Okay, let's see what that thing is. 102, and this number over here is 2 into 49, and for some reason that's not working. Okay. plus minus k. Okay, that looks right. All of that is also fine. Okay. To 6 square, 36, 9, 12. Okay. The other one should correspond to a equal to, okay, I think there's some limit on a or anything. No, nothing like that. In the last case is a equal to 2, n is equal to minus 2. So when all of that happens, what do we have? We have 3 into, okay, 3 into minus 2 whole square. So 3 into 4, and then 2 into minus 1 whole square. So 1. No, that they should at least satisfy that equation. Just give me a minute. They don't seem to satisfy that equation. So a equal to 1. Let's work that case first. A equal to 1 and a equal to 2. Those are the only cases. Right? So the numbers that we are looking at are a equal to 1 over there. So 2n square, m square and 2n square, m square and n plus 1 whole square. So now n plus 1 whole square minus 2n square must be equal to 2. Okay, let's just see if we are getting the right answers this time. So I would have minus n square plus 2n plus 1 is equal to 2. Yeah, that looks right. So you take that 2 over here, you get minus of n minus 1 whole square is equal to 0, which means n is forced to be 1. Okay. Oh yeah, that's what we got before. So here you would say this should look like 2m square and n plus 1 whole square, which means 2 square, and that is 4, meaning m square in this case is 3. That's a consecutive integers. So that's the story. Okay, let's work out a equal to 2 now. So now I should be having a plus 1 into n square, which means 3n square, m square, and a into n plus 1 whole square. The difference of these two again must be equal to 2. So what does that tell us? It tells us minus n square plus, you have 2n into 2, so that would give us 4n plus 2 is equal to 2. That's all. Okay. So what does that give us? So 2 and 2 is gone. Yeah, I think I made a small mistake there, but that's okay. The thing that we really are after is the value of a. Okay. Yeah, at least that looks fine. Anyway, so this tells us that n into n minus 4 is equal to 0. So n is equal to 0 or 4. Okay, so when n is 0, this looks like 0, m square and 2. So m square is 1 in this case. This is when n is equal to 0. When n is equal to 4, we'll start seeing some good answer. Okay, so let's see what we have. We have 2 times, okay, actually 3 times 4 square. So 3 times 16, which is 48. And then the next number, m square. And next we have 2 times 4 plus 1, that is 5 square. So 25 into 2, that is 50. And yeah, that works out, which means this number now is 49. And that's the largest possible value that we got among all the cases. We got 3, then 1, then 49. So since that's the largest value, we could say that m square has to be 49. Okay, good. Next, what do we have? We have m blue marbles, n red marbles on a table. These two people, I'll just call them A and B, Arman and Babita. A and B play a game by taking turns. In each turn, they pick a marble of their favorite choice. A starts first, and the player who picks the last red marble wins. For how many choices of M and N can Arman force a win? So forcing a win, that's an important word over there. So let's just call it the game of M blue marbles and N red marbles, right? So let's see what's going on over here. All right, so what do we have? Suppose let's take some simple cases. G of m comma 1. Suppose there was only one red marble, then what Arman could do is, all right, he's anyway starting the game. The one who picks the last red marble wins. So in this case, all he could do is pick that red marble and the game is done. So that's a sure win, which means GM m comma 1 is a definite win for Arman. Okay. Now let's think about GM2 and see what's going on. So now there are two red marbles in this situation, maybe lots of blue marbles over here, right? But only two red marbles. Now think about this. Arman should not be picking that red marble in the very beginning, because if he does that, then Babita will pick that and she'll win. So the only strategy that Arman could really apply is start picking blue marbles, because as soon as he picks the red marble, the game is done, because the very next step, the other red marble will be picked and Babita wins. That's not a forced win for Arman. So the only option that Arman has got is keep picking as many blue marbles. In fact, at no stage he's allowed to pick a red marble unless Babita picks the red marble. Whoever picks that red marble, the other person will win. So even Babita will try to make sure that she's winning. Okay. So if there are even if m is even, let's see what happens. Arman and Babita will keep picking red marbles because none of them want to pick they'll both be picking blue marbles. By the way, the circle means blue and the cross means red. I just don't want to use many colors. Okay. Now, their only strategy is to pick blue marbles and try to finish them off. Because as soon as someone picks the red marble, the other person will win. So it's not in their best interest to pick that red marble. Okay. Now, if there are even number of marbles over here, let's see what happens. All these things will get paired up, and then after every turn, the number of marbles will keep reducing by, the number of blue marbles will be keep reducing by 2. And then since it's even, at some stage it will be done. And then after the even number of moves, now the move is back to Arman. Now he has to pick the red marble. There is no choice. And then Babita will have to pick that the last red, and then Babita wins. So A loses, right? So it's not a win. I'll just write it like this. A doesn't win. If M is odd, then even in that case, they'll have the same strategy in their mind, which means they'll have to keep picking the blue marbles. Okay, they'll have to keep picking the blue marbles, but since that's an odd number, after an even number of rounds, as in after complete rounds, okay, after even number of turns, there will still be one blue marble left at the very end. When they are finishing up their blue marbles, there will still be one blue marble left, and then Arman will be forced to pick that, and then Babita will be forced to pick the red marble, and then the last one, Arman wins. Okay, so this way they could keep stalling all of that. Now you can keep continuing analysis of GM3 and so on. But what's going to happen is the blue marbles are only there to stall the game. Basically, the right strategy for, the right strategy for Arman would be, in fact, both of them would be to finish up as many blue marbles as they can. So let's think about that. So GMN, what I want to say is, if M is odd, let's think about, and let's say N is greater than 1. N equal to 1, they don't have to finish up the blue marbles, they can directly go for that one red marble and finish it up. Okay, so N greater than 1, let's see what's really happening in this particular strategy, where they just finish up the blue marbles first and they are only left with red marbles. Okay, if M is odd, then A wins if, let's see, odd number of blue marbles. So the first few rounds you keep removing as many 2s as you can. You will be left with one blue marble at the end, and then Arman, it's up to him whether he wants to pick that blue marble or go for the red ones. That depends on whether N is even or odd. Okay, so let's think about that. So this is just equivalent to one red marble over here. No, one blue marble over here, and then N red marbles over there. So this one has N marbles over here and only one blue marble. Okay, so let's say Arman goes for that. Then B, A, B, A, B. Babita wins. So if N is even, then Arman wins. Think about that. A, B, A, B, A, B, A. So A wins, and B wins if N is odd. Right? And there's a similar story. Maybe I'll just write it over here. Yeah, that's also the same thing for, same analysis for N equal to 2. In fact, you can reduce this case to G of M2, because now we have 3 marbles. If you remove one marble, you are into a forced situation of GM2, right? If you remove one marble from there, it's not like someone can win or something. GM2 is clearly determined. There is a way to win and it can be forced. So since it can be forced, even these games can be forced and so on. So inductively they'll keep building up to a forced game. Okay, so let's write down our conclusion. I guess I can remove this part. M even, then yeah, I didn't expect that. Okay, not too bad. There. All right, for how many choices of M comma N with M and N between 1 to 11, both included, can Arman force a win? Okay, so if let's think about that. N is equal to 1. Arman can win in all cases, all choices for M, right? Because Arman will definitely win if there is only one red marble. All he has to do is pick that red marble and he's done. So now there are 11 choices for the game to be won. There are 11 games where Arman can force a win. Okay, when n is greater than 1, you split it into even or odd. So suppose it is even, then Arman wins if Arman can force a win if m is odd. So if n is even, then m must be odd. Or else if m is even, then Babita can force a win. And in fact, I should probably write one more thing over here, which is m is even, then well, if n is even, what happens? They'll just keep finishing the blue pile and they are left with only red ones. Only red ones means the only scenario Arman can win is n is odd. N odd. And in the other scenario, Babita can force a victory, right? So that is one situation. Or else, if n is greater than 1 and odd, then n, not n, then m must be even. Hope I got that right. So if n is odd, no, I really didn't get that right. What I should be saying is, oh yeah, why not? That looks right. If n is greater than 1, even, then the only scenario where A wins, A can force a win is M is odd. So M is odd over there. And if N is odd, Arman can force a win when N is even. M is even, right? So those are the scenarios. Now, how many even numbers do we have over here? We got, well, N is coming from 1 to 11. So 2, 4, 6, 8, 10. That's all. So 5 choices for N and odd numbers for N. Meaning 1 up to 11, there are 6 odd numbers. Namely 1, 3, 5, 7, 9 and 11. Okay, so that's it. So in this case, we have 30 solutions. And let's think about this one now. Here you have n is odd, but I want n to be greater than 1. Meaning n is 3, 5, 7, 9 or 11. Still 5 choices for n. And let's see how many choices m has got. 2 up to 10. So there are again 5 choices. 2, 4, 6, 8, 10. So that is 25 scenarios. So in total, Arman has these many scenarios, which is 11. Yeah, so I'll just write it over here. 11 plus 25 plus 30. So that is 36 plus 30. So 66 games, 66 choices of M and N where Arman can force a win. In fact, the other scenarios, Babita can force a win. Okay, so that's that. Okay, let's go through the next one. You have ABCD is a rectangle, M and N are points on these two, assuming MC equal to, sorry about that. Yeah. M is over here such that MC is equal to CD. So m is somewhere over there. These two are given to be equal to each other. And then md is equal to mn. So md, whatever this length is, by the way, this fixes m. The very first condition fixes m, and then you have n over here. Does that mn is equal to md. And also cd, oh yeah, so you can put your compass over here, measure that distance and mark it on the side BC. If it hits it, there's only one point. But there's an extra condition which says CDMN lie on a circle, which means that CDMN is a cyclic quadrilateral. But since this angle is 90 degrees over here, the sum of opposite angles in a cyclic quadrilateral must be 180. So the other angle over there opposite to C, which is angle DMN, has to be 90 degrees. Okay. So now you can really work this out. You plug in 0, 0, and let's say L0. This one is LB, and then 0B. The first thing we would like to do is work out the coordinates of M. So let's say the coordinates of M. Well, we really know the y coordinate of M. It has to be B. So let's just call it x comma B. Right? And then N, we're going to call it y, not y. The x coordinate is fixed, it is L, and then y coordinate we are not yet sure. Okay, the conditions that we have is MC is equal to L. So let's say this length is L, this length is B. So the first condition I would write down is x minus L whole square plus B square is equal to L square. So that immediately tells me that x minus L whole square has to be L square minus B square. Right? And in fact you want, well, I can have square root with a plus minus. So x is equal to L. Think about this. If you take the plus sign, then x would be more than L. So it is not on the side AB. It is outside of the side. It's on the extended one. So the only reasonable choice would be x is equal to that thing over there. Right? Okay, so we have a concrete value for x now. Now let's think about n. Well, maybe the easier thing would be not the distance, but these two are perpendicular to each other. That's good enough, right? So that should tell us, okay, let's also write down the equation. We should be having x square plus b square is equal to x minus L whole square plus y minus b whole square. That is one equation which pins down the constraint that these two lengths are equal to each other. And also we would like to have the product of the slopes, which is y minus b, the slope of mn into the slope of md, you want that to be equal to minus 1. So from all of that you can really work the value of all of that, whatever we need. Okay, so y minus b divided by L minus x into the product of this slope, which is b divided by x, right? B minus 0 divided by x minus 0. This product you want that to be equal to minus 1. Okay. So we have a value of x. From that you will have a value of y. That's the constraint that x and y will have to satisfy. And that constraint will be imposed on B and L. That will give you an equation in B and L. So let's just call L by B, which is the quantity of interest. I'm just going to call that alpha. Right? So let's see what we have. We have x is equal to, okay, maybe I'll just expand that out. Okay, this thing over here, x minus L whole square, you can replace it with L square minus B square. So one more B square goes over there. So x square also can be worked in terms of y minus b whole square. Okay. That goes there, and then let's say it also comes to this side. So you would, okay, fine, let's just put it on that side. Minus, okay, so minus x into L minus x. Now, maybe I'll just go for it. So what do we have? We have minus x, so minus of that number over there. So minus L plus square root of L square minus B square. And then L minus x. L minus x is square root L square minus B square, right? So we really have the value of y. Now, all you got to do is take that information and put it over here. No, that's exactly what we worked. So we take this value and put it over there. Okay, so we can simplify this first. We have minus L into square root L square minus B square plus L square minus B square, right? So that is the value of this thing. I'll just take this value and I'll put it over there. And the rest of the things we already know the values. So we can just substitute over there. So let's do that. X square is L, the square of this quantity, right? So it is L square plus L square minus B square. So 2L square minus B square, right? So that is the value. Okay, we are not done yet. Minus 2L into L square minus B square. All of that is nothing but x square. That's all. So all of that is x square is equal to, let's remember that this piece was L square minus B square. So L square minus 2B square, if you put that over there. Okay. I guess we'll just put it over here because I want that to cancel with this B square over here, right? So on the other side, we have L square minus B square plus y minus b whole square. Y minus b whole square is all of that. So L square minus B square minus L into square root of L square minus B square whole square divided by B. Right? Because this is B times y minus B. So y minus B would be all of that divided by B square. So let's also divide by one more B square. So that would give us B square over here, B square over here, and B square over here. Let's write what that thing really looks like. Okay, I guess I can remove one equation. I'll remove this one. Okay, at least that looks right. So this piece is fine. I guess we can still keep that. L by B is alpha, right? So let's see what equation we have. Um, okay. Over here you have 2 times alpha square, 2 alpha square, and then that is gone. Then 2 alpha square root of alpha square minus 1 is equal to alpha square minus 1, and then you have all of that whole square. And then whole square. Okay. Okay. So what do we have? We have okay, that looks right. Give me a second. So you can take this quantity as some new variable and that will simplify a lot. Let's just check if I got the equation right. Okay, L square minus B square minus L into all of that divided by B square whole square is equal to all of this thing over here. So 2L square, no, just L square, right? So 2L square minus B square. So I guess I would cancel 1 alpha square on both sides. Suppose I take alpha square minus 1 and I call it beta. Maybe beta square is a better word. So that thing over there looks like beta square minus beta square plus 1 square root of that into beta, whole thing square, is equal to, okay, so I guess I got that beta has to be 2 and then no, beta has to be 1, then alpha square has to be 2 or something like that. Okay, you know what, let's go to the next problem and we can come back to this one. The thing is we don't have a lot of time, so that's the problem situation. Okay, so we have a polynomial p of x and then another q of x. You want to divide this by that and work out the remainder. So first we got to factorize this polynomial over here, which you can do that by just splitting the middle term, x square plus x square plus x plus 1, which is, if you take that common, which is also here, you would say x square plus x plus 1 taken common into x square plus 1. Right? Let R be the polynomial when this is divided by the polynomial. So by the way, the degree of this polynomial is 4. So if you divide P of x by Q of x, you'll get some quotient. I wish I could write Q of a capital Q of x, but that's already taken. I'll just write it as Q of x plus ax cube plus bx square plus cx plus d. That's because the degree of the remainder has to be less than 4. Okay, now what we do is we plug in the roots of these quadratics. Okay, these factors over here, we plug in the roots of the divisor. So one root that I can see is x equal to I, the imaginary root coming from this factor, x minus I into x plus I. So if I plug in I get I power 2025, which is also equal to I power 4 whole power 2024 by 4, whatever that is, into 5, and that's a natural number. So all of this is just I, because I square is minus 1, so I power 4 is plus 1. So I power any multiple of 4 will also be plus 1. Now we want this to be equal to, plug in I on this side. Well, over here you get 0 and you plug in I over there, you get I cube, which is minus I plus, actually minus, because b into I square, that would be minus b, plus ci plus d. And then this will tell you, by equating the real and imaginary parts, you need to have, well, the imaginary part is coming from minus a plus c. So minus a plus c has to be equal to 1, right? That's the imaginary part, and that has to equal to 1. And also minus b plus d has to be equal to 0. So that tells us that b is equal to d and c is equal to 1 plus a. So now the cubic looks like a x cubed plus b, which we don't know yet, and then c and d are fixed. C is 1 plus a times x plus d is b itself. Right? Now we plug in the roots of this quadratic, which are omega and omega square. You can just plug in one of them, the other one is the conjugate. So you can just equate real and imaginary parts and work it out. Okay, so what do we have? If I plug in omega, well, omega is this number. Omega is minus 1 plus minus I root 3 divided by 2. They are really the roots of this cubic. And by the way, omega cube is equal to 1. Alright, so if I do that, I get omega power 2025, which is, let's work out the remainder. 2025 is divisible by 3. So omega cube is 1, means this is also equal to 1. Therefore, we have the omega substitution in P will give us 1. In Q, let's see what we get. Not in Q. In Q, you'll just get 0 because that's the root of the divisor. In the remainder, what you'll get is A omega cube, that's 1, plus B into omega square, which is minus omega minus 1, plus 1 plus A into omega plus B, which means this is also equal to, let's simplify that a bit. Let's only group terms together and something should come out. Okay, so the omega part, let's write down all those terms which have omega. So you have a minus B coming from there, and then 1 plus A coming from that. And then the remaining terms, it is A minus B plus B. So this B and that B, they're out. So I guess we are only left with, that's all, A equal to 1, right? Plus A. So this should tell us that A should be equal to 1, and yeah, so equating real and imaginary parts, we get A is 1 and B is 1 plus A, which is 2. So that fixes everything, right? So that means that this quantity over here is x cubed plus 2, right? B is equal to 2, 2x square. 1 plus A is also equal to 2, 2x plus 2. So that is the remainder polynomial. Now all we got to do is plug in. So this is r of x. This is r of x. So r of 3 is what we are after. R of 3 would then be 3 cube 27 plus 2 into 3 square 18 plus 2 into 3 6 plus 2, and that is 8. If we add that up, we get how much? 45 plus 8, and that is 53. Okay, so that's the solution for this problem. Okay, this is one problem that I really didn't fully finish that, but okay, I guess then I can just jump to the next one. But my guess would be, the thing is, for every even number n, it works out. For example, just take 1, 2, 3, 4, n equal to 2. All you got to do is pair them up like that. You will have 1 plus 4 into 2 plus 3, and that is 5 square. Or in general, if you have n is even, n is equal to 2k, you would have all these pairings like that, and then the number of pairs would be even, and the sum within each pair is a constant. So it's a constant number, whole power, an even number, so that would be a perfect square. So n even will always work. Okay. In fact, my guess would be that only even numbers work, but that needs some work. So n odd, I'll let you know if I come up with a decent solution for that. Okay, so n odd, at least it doesn't seem to work for small values of n, but there must be some obstruction which really stops it, or there must be a solution that works. But anyway, a decent guess after this much would be, okay, for how many n in that set can it be split into? Okay, so basically all the even numbers. So 2 up to 36, that's 18 of them. So I guess I would go with 18. Yeah. All right. Consider a sequence of real numbers of finite length. The consecutive 4 terms are strictly increasing. The averages are strictly increasing. The next 7 consecutive 7 terms, those averages are strictly decreasing. Okay. What's the maximum possible length of such a sequence? All right. So an plus 1 plus an plus 2 plus an plus 3, that's the average of the okay, so let's say my sequence is a0, a1, a2, and so on. It's a finite length, so I don't know where it stops, but it stops somewhere. So this quantity, that's the average at stage n. That's the 4-term average at stage n. Now at stage n plus 1, it must be greater. So strictly less than an plus 1, an plus 2, an plus 3 plus an plus 4, whole thing divided by 4. So that is all the information that's captured in the first part of the sentence. And that's equivalent to, once you throw these things out, that's the same thing as saying an must be less than an plus 4. And similarly, the other thing it says 7-term averages must be strictly decreasing. So an plus 1 up to an plus 6, whole thing divided by 7, must be greater than the similar expressions, but starting from n plus 1 going all the way up to n plus 7, whole thing divided by 7, right? So these two are gone, and that's the same thing as saying an must be greater than an plus 7. This is for all n, and this is also for all allowed choices of n, right? And it's a finite segment, so all allowed choices. Okay, let's see what that tells us. So we first learned that an has to be less than an plus 4, and also an has to be greater than an plus 7 for every choice of allowed values of n. Okay, now since an is less than an plus 4, you can chain it up by saying that should be less than an plus 8, and so on, meaning a has to be less than n sub every multiple of 4 for k greater than equal to 1. And also a similar consequence that comes from here is that an has to be greater than n plus 7 times L for every possible value of L greater than equal to 1. Now the problem is, if you think about A versus, okay, so let's think about 28. 28 is the LCM of 4 and 7. So what I see is, okay, by the way, that's an. So an must be less than an plus 28, and also that will tell me that an has to be strictly greater than an plus 28. All I'm doing is plugging in L equal to 4 over here and K equal to 7 over here to get that. But that's a contradiction. That can never happen, right? Because you want a number to be greater than the other number and also vice versa. So that never happens, which means if A0 is a term, then A28 must not be a term. That means the number of terms should be less than equal to 28. If you had A0 up to A28, then that would be 29 terms. So you don't want that. Therefore, the number of terms has to be less than equal to 28. Okay, what's the maximal possible length of such a sequence? And turns out you can actually construct one when n equal to 28, it's possible to construct one just to demonstrate that it's possible, one such sequence. And you would just do A0, A4, A8, maybe I'll just briefly give you the idea. A24, there won't be A28 because A27 is the last term. So A27 is the last term. By the way, if I'm calling that n, then maybe I should write n minus 1 over here because I'm starting my index from 0. Okay. So all I did was just take some values 0, 4, 8 and so on. You want these things to be chained up like this, and then 0 has to be greater than A7, A14 and so on. You can take this to be 0, this has minus 7, minus 14, minus 21, there won't be minus 28. And the next layer you can compute it again. All I'll do is just keep increasing these things by 4, these things by decrease by 7, and you'll get a sequence, it will work out. Now what happens when you plug in a equal to 1? As soon as you plug in a equal to 1, you'll see exactly one term which works out computationally. In fact, when a is equal to 1, this thing here you will have a1 greater than a8 greater than a15 and so on. But a8 we already worked out the value, we want that to be 8. Just keep subtracting 7 and you get 1 here, you keep adding 7 and so on. This way you can construct the sequence and you can verify that that sequence satisfies the required property and has a length of 28. And we just realized that the length cannot be more than 28. Therefore, the maximum possible length of such sequences must be 28. Okay. All right, just a few more. So what do we have? We have A, B, C are natural numbers from 1 to 50. And then they satisfy that relation. So this relation, I'll swap it using the GCD. I could say it is A times C divided by D1, where D1 is the GCD of A and C. And similarly, let's call D2 as the GCD of B and C. So I would have AC by D1 plus BC by D2, whole thing divided by A plus B is equal to 26C divided by 27. You can take C common, bring it out and then strike it out with that. By the way, D1 divides A, so that is an integer and all these things are integers, natural numbers, right? So let's rewrite this thing. We would have 27 times A by D1 plus B by D2 is equal to 26 times A plus B. Okay, now that immediately tells you that 27 divides A plus B into 26, but then since GCD of 27 and 26 is 1, so Euclid's lemma will tell you that 27 has to divide A plus B. Therefore, A plus B has to be some multiple of 27. And A and B are values from 1 to 50. So K can't be too big, which means K has to be 1, 2 or 3, because 4 times 27 you cross 100, right? I mean a plus b would at most be equal to 100. So 4 times k, you'll cross 100. So that's not allowed. Okay, so that's that. Now let's plug that in back over here. What do we get? We get 27 times a by d1 plus b by d2 is equal to 26 into 27k. 27 is gone and we are left with 26k, which I can write it as 27k minus k, right? So that is a plus b, because a plus b is 27k minus k. So that tells me that a minus a by d1 plus b minus b by d2 is equal to k. Let's just call this number as capital A, this number as capital B. So what do we have? We have A equal to A minus A by D1, B equal to B minus B by D2, and A plus B is equal to K. And also D1 and D2, they are really GCDs of all these things with C. Okay, let's do some case analysis. So we have case k equal to 1. If k equal to 1, then a plus b is 27k, which means a plus b has to be 27. And then capital A plus capital B is equal to k, which means it is equal to 1. And note that these things are non-negative numbers. They are greater than equal to 0 and they are whole numbers, right? So that means that A is equal to 1, B equal to 0, or A is equal to 0, B is equal to 1. So the subcase A equal to 1, B equal to 0 means, what is A? A is A by A minus A by D1, that is equal to 1, and then B minus B by D1, D2 is equal to 0. So this tells you, well, it immediately tells you that D2 has to be equal to 1. That's the information that you get about D2. And then D1, you still get a lot of information. All you got to do is D1 minus 1 divided by D1 is equal to D1. Now, again, you would say D1 minus 1 divides D1, but it's co-prime to D1, which means it divides 1. That means it has to be equal to 1, which means D1 has to be equal to 2. So D1 and D2 we could work out from here. All you got to do is take D1 value as that and plug it back over here. You get A minus A by 2 is 1, which will tell you A by 2 is 1 and A is 2. If A is 2, then A plus B is 27. That tells you that B is 25. So A equal to 2, B equal to 25. Let's think about C now. C must be such that GCD of A with C must be equal to D1, which is given to be 2, and also GCD of B and C, you want that to be equal to 1. So A and B are fixed in this subcase, and then B and C has to be worked out to satisfy this. So first things first that comes out of this is 2 has to divide C. In fact, that's equivalent to that. There's no more information that's in that. It just says 2 has to divide C. This one says phi should not divide C. C has to be co-prime, that's phi square. So C should not have phi as a prime factor. So how many cases does that give us? How many solutions does that give us? All multiples of C, all multiples of 2 from 1 up to 50. Let's remember that all these numbers are maximum up to 50. So how many even numbers are there? There are 25 even numbers, but in that we don't want those numbers to be divisible by 5, but they are already even, which means those numbers are actually divisible by 10. So those numbers you don't want, 10, 20, 30, 40 and 50. So you have 20 cases in this subcase. Let's also work out A equal to 0, B equal to 1. Okay, so it's actually quite similar to this analysis. You'll get 20 more. And if you work out the other cases, k equal to 2 and 3, you'll get no solution over there. You'll realize that the values a and b have to be quite small, and that doesn't add up to a plus b equal to 27k. It really doesn't add up. There's no solution there. So I won't bother you with all that computation. I'll just work out this computation and then conclude there are 20 more solutions. So what do we have? Now a minus a by d1, you want that to be 0, which means d1 is 1. And also b minus b by d2, you want that to be equal to 1. That's the same equation as this, by the way. So that tells you that d2 must be 2 and b must be 2 again. Right? So now let's work out the story for C. Now A is, well, A can be, if B is 2, then A has to be 25. That's because A plus B is 27. So 25 must be co-prime to C. And then B and C, well, B is 2 and C is C. That thing must be 2, right? So again, same story. 2 has to divide C, and then 5 should not divide that, and you get 20 more solutions. So in total you get 40 solutions. You can work out the other cases. It's quite similar to this, and you'll realize that there's really no solution over there. Okay. Okay. Now a is a positive integer, which is not a perfect square. X and y are non-negative integers, so that all of that is true. Now what's the largest possible value of a? Alright, so first things first, we write down that square root of a has to be greater than or equal to y. Because the thing is, we are planning to square that. If you want to square that, you want this to be greater than or equal to y. And then we would have x minus square root of x plus a is equal to square of that quantity, which is a plus y square minus 2y square root of a. Now let's think about that. Yeah, that's all right. Now there's a possibility. Look, if y is not equal to, so let's analyze y is not equal to 0 case. If y is not equal to 0, what happens? You have a surd over there because a is not a perfect square. You have some root of some square free number still on that side. So what should be happening is these two quadratic surds must be equal to each other, which means their conjugates should also be equal to each other. So if you work that out, you'll realize that these two numbers should really match up, and square root of x plus a must be equal to 2y square root of a, right? Which is the same thing as saying x plus a must be 4y square a. But x itself is a plus y square. So this would be 2a plus y square, which means y square common, 4a minus 1 is equal to 2a. There's really no solution for that, because 4a minus 1 will be greater than that number. Minus 1 is greater than 2a. So this thing has no solution. In the case y is not equal to 0, therefore y has to be equal to 0, right? Once y is equal to 0, you see fewer terms here. X minus square root of x plus a is equal to a. That's all, right? Okay, now you just move that there. This a comes to this side. Maybe I'll just write it over here. X minus square root of x plus a is equal to a. So x minus a whole square is equal to x plus a square root and then whole square. So that would remove the square root and cancel out the square, which So you would have x square minus x into 2a coming from the cross term over here. From there you'll have one more x coming, but we have already have the minus sign out, so that works out. So a square minus a is equal to 0, right? So y has to be equal to 0, and then x has to satisfy this equation. Let's think about that. It's a monic quadratic. The leading coefficient is 1. The sum of roots, product of roots are both integers. You want x to be a non-negative integer, which means both the roots will have to be integers, right? Because sum of roots is an integer, and if x is an integer, then the other root should also be an integer. So the criterion for that is the discriminant must be a perfect square. So the discriminant is 2a plus 1 whole square minus 4 times a square minus a. That must be a perfect square. Let's see what that tells us. So if you expand that out, 4a square, that will cancel with the 4a square over here. You have 4a plus 1 plus 4a. So that would give us 8a plus 1 must be perfect square, right? So that doesn't leave a lot of options. So 8a plus 1 is a perfect square, and also you want the largest such a that does this job. So this m, maybe I can write it as 2l plus 1 whole square, because that's an odd number. That's an odd square. So m has to be odd. So that would be 4l square plus 4l plus 1. So what does that tell us? It tells us that a is l square plus l by 2. Yeah, that's a triangular number, l into l plus 1 by 2. The largest value I can think of is, think about this, 13 into 14 divided by 2. What is that? That is 91, and that is less than 100. If you take 14 into 15 by 2, you have crossed it. So the best value of a is that number. Therefore largest a is 91. Okay. Alright, just two more questions. So a regular polygon is said to be colorful if it is possible to color using at most 6 colors, so that every vertex is colored with exactly one color. Okay, and such that any 5 consecutive vertices have different colors, right? So if you have whatever color you have, so every consecutive 5, right? So 1, 2, 3, 4, 5. All these things must be of different colors. Okay, now find the largest n for which a regular polygon with n vertices is not colorful. What is the meaning of that? We need to understand the meaning of that. That says that there must be a cutoff. So let's call that number n, beyond which every regular polygon with at least n vertices, at least if the number of vertices of a n polygon is at least n, then you will be able to color it using these things, right? Okay, so the thing is, first things first, okay, all right. Let's start coloring it this way. Suppose I use 1, 2, 3, 4, 5, and then I just keep using 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. Let's say if this n, okay, this one I'm calling it as the largest possible n. Okay, not like that. I won't need this capital N, that was just to explain the point. Okay, so suppose n is a multiple of 5. If n is a multiple of 5, then all I can do is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and just cycle it up. Eventually, this will come back as like that. It will come back as 4, 5, and it will go in a cycle. And this satisfies the condition, which means all multiples of, which means this is a colorful polygon. You can color it. There's no toughness over here. All you got to do is take 5 colors and just keep cycling those 5 colors like that, and you'll see that every multiple of 5, if the number of sides is a multiple of 5, then that polygon can be colored. Okay. Now next one, let's try something interesting now. Okay, if I have 6 over here, and then I do 1, 2, 3, 4, 5, chain it up, it chains back, right? So if I have 5k plus 1, this is also colorable, provided k is greater than equal to 1. There should be at least one block here, and even here k should be greater than equal to 1. Zero-sided polygon, no, we're not talking about that. So 6 vertices, you can color them. Then if you have more vertices, if you have a 5k plus 1 vertices, just keep putting 5, 5, 5, 5, 5, and the last one 6. That is a valid coloring. So these things are also colorable. Now let's try out 5k plus 2 and things like that. This one I could do it like 6, 1, 2, 3, 4. That's 1, 2, 3, 4, 5. 6, 1, 2, 3, 4. And then I can put 5 and 6 and then go on with 1, 2, 3, 4, 5. Right? Those are complete blocks. It will chain back to this thing. So you need at least 2 of these things to have a 5, 6 combination over here. Meaning 5k plus 2 is also colorable provided k is greater than equal to 2. There should be at least 2 blocks over here to get this cycle up to this point. So 5k plus 2 eventually will also be colorable. Not just eventually. From k or 2 onwards, you can do it. For k equal to 1, 7-sided polygon, you won't be able to color it. You can try it out for a while. You won't be able to do that. Okay. So let's think about 5k plus 3 now. Looks like all remainders of 5, it's just possible. But it will only be possible eventually. So we have 1, 2, 3, 4, 5. Then 6, 1, 2, 3, 4. Then 5, 6, 1, 2, 3. And then we have 3 as the remainder. So you can put 4, 5, 6 over here. That's the remainder part. And then keep continuing your story, which is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like that. Right? It chains back to this one. In fact, I don't want to do anything complicated. I'll just put the same 1, 2, 3, 4, 5. And that tells you that you need at least 3 blocks to make that happen. So n equal to 5k plus 3 is possible provided k is at least 3. You can color it in the satisfying all the rules, but you need at least 3 blocks to make that happen. Once you have that, you can color it. The remaining 3 you can put 4, 5, 6, and the rest of the blocks you can just go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so on. Okay. Now n equal to 5k plus 4. Let's just think about this one. We have 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Okay. Okay, never mind. So we have 4, 5, 6, 1, 2, and then 3, 4, 5, 6. You can just leave it like that. And then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You keep repeating this how many ever times you want. Now that's a valid coloring. But here it seems like you need quite a bit to get this thing. You need 1, 2, 3, 4. So these things are colorable provided k is at least equal to 4. Right? So the conclusion is, last problem. So the conclusion is phi, now every number is phi k or phi k plus 1 or phi k plus 2 or 3 or 4. Every number can be written like that. Now, if k is greater than equal to 4, then all these numbers you can color them properly, which means from 20, if the number of sides is greater than 20, it's possible to color it, right? The only problem is below 20. So what are they asking for? They are asking for the largest number n for which a regular polygon cannot be colored. So 20 onwards, everything can be colored. And then the previous cases, 15 is a multiple of phi, so that all multiples of phi can be colored. Then 16 can also be colored. What about 19? 18 you can color because k equal to 3, that gives you n equal to 18. But 19 you cannot color, and 19 would be my answer. And well, you just have to check that there is a color, there is no way to really do that. That's also a task, but doing that verification, you'll land up with that's the largest possible value. Okay, last question now. So we have a circle of radius 10 with center O. Now S1, S2 are circles which touch them internally. So we have a circle here, S1 and S2, right? They meet at A and B. Now the other circle, I don't know where my other circle is, but let's think about that. That big circle has to touch both these circles internally, and these two circles are intersecting at 2 points, and also OAB is 90 degrees. So AB is this one, OAB is 90, means O must be somewhere over here. I don't know where, but that must be O, and this must be 90 degrees. I guess it's probably on the other side. Okay. I'll draw a smaller circle. Okay. Now, this is the center of this circle. Let's just call it O1. The center of this circle, I'll just call that O2. Now, we have a circle which passes through, which touches both these circles, and the center is somewhere on, okay, that really doesn't look like the center. Maybe over there, that's O, right? Probably on that side also, I don't know, but that's O. Okay, I hope that's good enough. All right, now what do we want to compute? What is the sum of the radius of S1 and S2? So this circle is called S1, that is S2, and this circle is S. The radius of the big circle is given to be 10. Radius of smaller circles, we'll just call them R1 and R2. The thing that we are after is R1 plus R2. So let's just keep that over there. Now the first thing is, the line joining the centers of these two circles must be perpendicular to this chord, to the common chord, right? AB is perpendicular to O1, O2, which means these two lines are parallel to each other. Now, as soon as you take A to be the origin, this simplifies quite a bit. And let's say this one is, well, both the O1 and O2 need to have the same y coordinate. So even if we don't know what that is, I'll just call this y0 as the y coordinate and x2 as the x coordinate. And here it should be x1 comma y0. And let's say this point over here is some a comma 0. We don't know what that a is. In fact, we don't know anything yet. But that's the situation. There are these few points that seem to be important. Okay. Now the thing is, when two circles touch internally, like for example S and S1, they touch internally, then what happens is the difference of their radii must equal to the distance between the centers. So let's write that down. The distance between the centers, where are the centers? The centers are here and over there. So O and O1 are the centers. So the distance between them is x1 minus a whole square plus y naught square, right? Must be equal to, well, that's the square of the distance between these two centers. So it must be equal to 10 minus the distance between these two. The distance between these two centers is r minus r1, right? So 10 minus r1 whole square. That's the first equation. And then similarly, you have x2 minus a whole square. Look, all I'm doing is just working that out. So x2 minus a whole square plus y naught square must be equal to 10 minus r2 whole square. And also, we need to catch this one, that a lies on both the circles. So how do we catch that? A lies on both the circles. Okay, so maybe I'll just write over here. So distance between A and O1, that is x1 square plus y0 square is equal to r1 square, right? r1 square, and also x2 square plus y0 square is r2 square. Okay, let's add, these are standard tricks. You can just add these two equations, then subtract them out, and then it will work out. Okay, so if I subtract these two first, what happens is, I'll have x1 square minus x2 square minus 2 times x1 minus x2 into a. The a square term get cancelled, plus y0 square also is cancelled, and over here the 100 is cancelled. You will have r1 square minus r2 square minus 20 times r1 minus r2. And similarly, if you subtract these two, you get x1 square minus x2 square is equal to r1 square minus r2 square. And you can use that information and plug it over here. r1 square minus r2 square. So this thing and this thing, they are exactly the same thanks to that equation. So we have these two cancelling out. So what's left is x1 minus x2 times a is equal to, okay, the minus and minus I have removed, 2 and 20, we cancel that a bit. So 10 times r1 minus r2, right? That's the first equation. And then you can add these two things up and see what we get. So, by the way, the x1 square plus y0 square, I can cancel that with r1 square because of that equation, right? So over here itself, I'll just write it as minus 2ax1 plus a square, right? That's what we have over here, plus y0 square. Y0 square became r square, r1 square, and then that cancels the r1 square. So we are just left with minus 2a x1 plus a square is equal to 100 minus 20 r1. And similarly, we would have minus 2a x2 plus a square is equal to 100 minus 20 R2. If you add these two things, by the way, if we subtract these two equations, this is what we got. Now, if you add these two equations, what do we get? So we have 2 minus 2a into x1 plus x2, right? Minus 2a into x1 plus x2 is equal to 200. Okay, I'll just write this 2 into 100 minus 20 times R1 plus R2. I can cancel 1 2 from everywhere and I'll be left with that, right? Okay, so let's write these three equations. I'll write it in the next page. This one and that one, right? Okay. So the first one is, we are almost done. X1 square minus x2 square is equal to R1 square minus R2 square. So maybe I can just factorize these things and start like that. So x1 square minus x2 square is the same thing as x1 plus x2, x1 minus x2, and that is equal to R1 minus R2, R1 plus R2. Then the next equation that we have is over here. X1 minus x2 into a is equal to 10 times x1 minus x2 into a is equal to 10 times R1 minus R2. And the last equation that we have is minus of a into x, that all of that, right? So you can move terms or just keep it like that. Minus a into x1 plus x2 minus a into x1 plus x2 is equal to, I guess it's 100 on that side. That's right, 100 minus 10 into R1 plus R2. Minus 10 into R1 plus R2. Okay, now from these two equations, you can make some simplifications, namely x1 plus x2 into that thing. I can replace it by, okay, just think about it like, okay, fine. X1 minus x2 is 10 times R1 minus R2 divided by A. Well, you might say, is that a safe thing to do? But fine, I'm just doing it. And okay, what do we have? So this piece is equal to R1 minus R2 into R1 plus R2. And this, you just throw it out. And we hope that the radii are different. Anyway, so what we have is R1 plus R2 is now equal to x1 plus x2 divided by A. So you take this thing and you plug it over here. So minus A into x1 square, x1 plus x2, which is A by 10 into R1 plus R2 is equal to 100 minus 10 times R1 plus R2, right? So x1 plus x2 is A by 10 into R1 plus R2. That's what I plug over there. And then 10 minus, okay, so looks like if we figure out the value of A, we are through. But let's see what that looks like. How did I do it? Okay, R1 plus R2 is equal to 10 times x1 plus x2 divided by d. Okay, next minus d square by 10 R1 plus R2 plus d square. Oh, so that's the term I missed. plus over here you have a square and a square. I forgot to add that over there. It must be plus 2a square. I see. So that was the catch. Plus 2a square is equal to all of that. So I should also write it over here. Maybe it would be just a square now, right? Because we also divided by 2. So I'd be having plus a square. Okay, let's see what all of that is. So I have a square minus a square by 10 into r1 plus r2 is equal to 10 into 10 minus r1 plus r2. And over here it is a square by 10 into 10 minus r1 plus r2. Yeah, so all I did is either a is 10. Let's see if a equal to 10 makes any sense. A, if it is equal to 10, then the distance between O and A would be equal to the radius of the big circle. Anyway, that gets ruled out. So what should happen is these two factors, you can't just strike them off. Therefore, 10 must be equal to R1 plus R2. Right? Just think about what happens. The points are inside, so A cannot be equal to 10, which means you can strike those factors out. In fact, let's just see what that term is. This would tell you that 10 minus of R1 plus R2 whole thing multiplied with A square by 10 minus 10 is equal to 0. This factor can be safely removed. Therefore, R1 plus R2 is equal to 10. All right, cool. Yeah. Thank you. Thank you for your time and hope you had a good job. Okay, there. Let's just see if oh, this one, yeah, this is one problem we didn't do. But other than that, I think, yeah, we got them all. Yeah, also there was one problem with alpha, but I'm sure you can work it out. I got the answer in my paper. So, okay, thank you for your time. Thanks a lot.